In this video, we're going to talk about how to try to get an equation of a sine or a cosine from the graph. So we're kind of going the opposite direction from what we've been doing for the most part. So we're going to get something that's either in the form of y equals a sine b times x minus c plus d, or y equals a cosine b times x minus c plus d. So there's some flexibility in the order you do these in. So you may see one part of this in a different order than the way I do it, and that's fine. The first thing we have to do, though, is decide where are we going to consider this curve to start, because there are actually many different looking equations for this same graph. So if we imagine it starting at this point right here, then since that's starting at a high point, that would be a positive cosine curve. If we imagined it starting right here, since that's in the middle of the graph, and the graph goes down for loop below, that would be a negative sine curve. If we imagined it starting right here, since that's a low point on the graph, that could be a negative cosine curve. And this could be a positive sine curve because we're starting in the middle, and it's going to be a loop above immediately to the right of that. And likewise, this could be a positive cosine curve, a negative sine curve, a negative cosine curve, and a positive sine curve. So I'm going to just, I'll do a couple different ones, but I'm going to start right here with this one. So if we imagine that starting at that high point, which is a negative, which occurs at a negative 16 degrees, then it's going to be a y equals, I'm going to leave a space here because I'm not sure what the a is yet, but I've committed to making this a cosine, and I'm not sure what the b is yet. I'll get to that. And since we're going to start it at a negative 16 degrees, then this is going to be an x plus 16 degrees is going to be inside that cosine curve, that cosine equation. So next, what I'm going to look at is it's got a high point of 18 and a low point, it says right here, of negative 2. So that means that the max minus the min divided by 2 is going to be our amplitude. And so that's for us going to be 18 minus a negative 2 divided by 2 is going to be 20 over 2 is 10. So that's going to be then a 10 that goes, I'm going to erase this now and put the 10 in that spot there. That's our amplitude. Now the next fairly easy one to see, I think, is the midline. So right here is the midline, and that's going to give us that translation vertically. That's going to give us the D. So we can see that our amplitude is 10, and our low value is negative 2. So going up 10 from the negative 2 is going to put us then at a positive 8. Or you can also see it as going down 10 from the high point. Those should be in agreement, and they are. So that's going to be an 8. Now always the hardest part is going to be figuring out what is this b. So what we have is that since we're in degrees, our normal period for a sine or a cosine in degrees is 360. If we didn't see that degree bubble, it would have been radians, and that would have been a 2 pi. Now we know that we're going to take that 360 divided by the b, and that's going to be the actual period of our graph. Remember, that's how we did it when we were graphing. So we're going to look at our graph here and try to figure out what that period is, and then solve for the b. So, and we can actually, let's do it before we get the actual number. So if we multiplied that b to the other side, that would be b times the actual period. And so then if we divide the period over, the b that we're looking for here is going to be the natural period, which will be either 360 or 2 pi, depending if we're degrees or radians, divided by the actual period of our graph. So to find the period, we can look for a few different things. We can look for the horizontal distance from a high point to another high point, or from a low point to another low point, or from a middle point. But then we have to make sure we include a loop below and a loop above before we go to the next place there. I'm going to just look, since we're imagining this starting at negative 16 degrees, I'm going to go from the 24 to the negative 16. So that's 24 minus the negative 16 is going to be 40. So that's our actual period. So our B, the B that we're looking for here, is going to be the natural period, which is 360 degrees, divided by the actual period, which is 40 degrees, and that's going to be 9. And so that number B is going to go right here as a 9. So this is one possible correct answer for an equation that gives us this graph. Let's just do another one. I'm going to do one and imagine it starts right here, just so you can see it from a different perspective. That's starting in the middle, so that would be a sine curve. And because we can see it goes down immediately to the right, that's a reflected sine curve, so it's going to be a negative sine curve. Again, we're going to start that at negative 6 degrees, so that's going to make this be an x plus 6 degrees. We can see the midline remains the same, so that 2 is going to be 8, and the amplitude is still going to be 10, and for us that it's going to look like a negative 10 because it's a reflected sine curve. And again, our period, we could say that this started at negative 6, it did the loop below, loop above, going to 34. So 34 minus the negative 6 is that same 40 that we got before, making the B again the 360, the natural period, divided by the 40 degrees is still going to be 9. So there is a second equation that is also works for that graph. And there are others. Okay, let's move across to the next one. And so if we look at this one here, let's maybe just to make it different, let's imagine that this is going to start here at this low point. So since that's a low point, that's going to make that be a negative cosine curve. So we're going to call that y equals a negative. I'm going to leave a space here because we're going to figure out what the amplitude is. And I'm going to leave a space again for the B, whatever that is. And since that's starting at a positive 110, then I'm going to make that be x minus 110 degrees. So again, this number, this A, is going to be our amplitude. So we're going to take our maximum minus the minimum divided by 2. And so that is going to be a 6. So we are going to get in this spot here a negative 6, negative because it's a reflected cosine, 6 because that's the amplitude. We can see the midline right here is going to be then from the low point up to here is going to be the low point 3 plus our amplitude 6, or that's the same as 15 minus the 6. Both of those are going to take us to a 9. So that's going to make that midline 9. That's our vertical translation. And now here again, finding the hardest part is that B. And remember, we're saying that B is going to be the natural period, which if we're in degrees is 360, divided by the actual period. So let's see, an actual period, I've got a low point here at 110. Let me change colors so we can see it. Here's 110. Here's the other low point that we can see the x value for. So I'm going to take right minus left. So our period is going to be the 110 minus the negative 70. That's going to be 180 degrees. So our period for this graph is going to be 180. That's going to make our b be 360 rather, divided by the 180 is going to be 2. And so that's going to be our b that goes right here. And there is one possible equation for that graph. All right, I'll let you do the others. I'm going to move, there's a blank page next. I'm going to move to there and do some other things. So since I have a blank page here, what I'm going to talk about here is a different kind of problem. So I'm going to ask you to find theta, where theta can be between 0 and 360 degrees. And also, we're going to do this in radians from 0 to 2 pi. So I want all possible angles in one trip around the circle where the sine of theta is a negative 1/2. So here's how this might work. I'm going to ignore the negative sign for a minute and first think about what is the angle whose sine is 1/2. Now hopefully we're knowing this from memory. So the angles go, they're going to go 0, and then pi over 6, and then pi over 4, then pi over 3, then pi over 2. And sine starts small and gets bigger, so it's going to go 0 and then 1/2. So we know that, I don't think I wrote that right. Hold on there. I think I said it right but wrote it wrong. This is pi over 6 and this is pi over 4, and that's the pi over 3. So the sine of pi over 6 is equal to 1/2. So this I'm thinking of as my reference angle. Keep writing the wrong thing. Okay, so pi over 6 is the reference angle. Now we want to know where is sine going to be negative. So we think, well, sine is the y value, so it's going to be negative in quadrants 3 and 4. Our reference angle, we said, is going to be pi over 6. So we're going to have to go in a positive direction because we want our angles to be between 0 and 2 pi and 0 and 360. So if we go, this is going to be pi plus another pi over 6. That's 1 1/6 pi. That is, theta is going to be 7 pi over 6. We also can get there by going around this way. So I'm going to think of that as going 2 pi all the way to here, then backing up pi over 6, the reference angle. So 2 pi is 12/6 pi. And then if we subtract 1/6 pi from that, that will make this angle be 11 pi over 6. So there's the two angles in radians. Now we want to do the same thing in degrees. So in degrees, this first angle would be 30 degrees. And so that would make our reference angle 30 degrees. So this angle here in quadrant 3 would be 180 plus the 30 is going to make that first angle in quadrant 3 be 210 degrees. Similarly, we're going to go 360 back up 30. So 360 minus the 30 degrees makes that quadrant 4 angle 330. These are the angles we're looking for, and that's our reasoning through that. Let's try another one. I'm going to make this a little maybe tougher. We'll say cosine of theta is equal to, and let's say we'll go negative square root of 2 over 2. So again, first we're going to ignore the negative part. Let's get our reference angle. So what angle makes cosine square root of 2 over 2? Well, this is where we're going to go. Remember, cosine starts big, so it's going to be 1 square root of 3 over 2. Square root of 2 over 2 is right there at pi over 4. Now that's our reference angle, is going to be pi over 4, or 45 degrees if you want. And then we need to know which quadrants is cosine going to be negative in. Cosine's the x value, so that's going to put us in quadrant 2 and quadrant 3. So if our reference angle is a pi over 4, then the angle we're looking for is going to be pi minus 1/4 pi. So 4/4 pi minus 1/4 pi is going to be 3/4 pi, or 3 pi over 4. Similarly, this angle in quadrant 3 has a reference angle of pi over 4, so we can go pi, which is 4/4 pi, plus another 1/4 is going to make that 1 1/4, or 5/4 pi, or 5 pi over 4. In degrees, this is going to be, our reference angle is 45 degrees, so if we take the 180 minus the 45, that's going to be 135. So that's a 135 degree angle. Or in quadrant 3, we'll go 180, and then plus another 45 is going to make that be 225 degrees. Okay, let's do one more. We're going to do this as a tangent of theta is equal to, we'll say, -1. Now tangent theta, again, ignore the negative sign for a minute. Remember, tangent theta is sine over cosine. So for this to be equal to 1 means that sine theta and cosine theta must be equal to each other. Now the only place in our known angles here where sine and cosine are the same is at that pi over 4 or 45 degree angle where sine and cosine are both equal to square root of 2 over 2. And we know that square root of 2 over 2 over square root of 2 over 2 would in fact be equal to 1. So our reference angle is going to be pi over 4 or 45 degrees, depending if we're radians or degrees. Now, tangent is positive, I guess negative rather, in the quadrants where the x and y values are different. So in quadrant 2, we have a negative x and a positive y, and in quadrant 4, we have a positive x and a negative y. So the quadrants where tangent is negative are going to be quadrants 2 and 4. So in quadrant 2, that angle, remember our reference angle is 45 degrees, or pi over 4. So in degrees, that's going to be 180 minus the 45. That's back to 135. In radians, that's going to be pi, which is 4/4, minus 1/4. We'll make that be 3 pi over 4. In quadrant 4, our reference angle goes to the nearest x-axis is 45 degrees, so we would go 360 back up 45. 360 minus 45 is 315 degrees, or 2 pi, which is 8/4, minus the 1/4 pi would be 7 pi over 4. All right, very good.